The last module, applications of spherical trigonometry. The first subtopic that we have here is the terrestrial sphere. Considering the Earth in this portion, okay, so we do have, then here we do have the South Pole, and then we are also aware that in between is the equator, okay, and then have the northern hemisphere, okay, this portion it is above the equator, and then the southern hemisphere. A bigger view of the Earth. So we're already familiar with this. This is just to show to you. So as what you can see, the red line here is the equator, and the Philippines is here. Okay, it is above the equator. So the North Pole is in this portion. Okay, and then South Pole is here. So the North Pole, the line that connects the North Pole and the South Pole is actually the axis. Okay. Then so above the equator, this is the northern hemisphere. So we can see that the United States, what else? So India, China, Russia, Greenland, okay? Um all those are what? On the northern hemisphere of the earth. While Brazil, okay, this portion of Brazil here, this portion, then Australia, okay, New Zealand here, um, those can be found in the southern hemisphere. So on the next slide, we have here the term meridian. So what is meridian? Meridian is described as a semicircle of great circle. I hope that you can still remember what is a great circle. It is the biggest circle that you can have. Okay, it is the biggest circle on a sphere. So if the sphere will be caught um, with a plane in which the plane will pass through the center of the sphere, so the great circle will be formed. And half of the great circle, if we're gonna consider the earth, okay, if we're gonna consider the earth, so the great circle's half, which is a semicircle that passes through north and south poles. So we do have if we have the north here, okay, this is the North Pole, this is the South Pole. It is said that the meridian is semicircle from north, okay, to south or south to north. So as what you can see, this red, okay, the red semicircle is actually a meridian, okay, as well as this semicircles, all the vertical, okay, the vertical semicircles that you can see are called meridians. And then every meridian intersects the equator. So if you can remember, so in between the North Pole and then the South Pole, so the equator, we have it here. So it is said that the meridian intersects the equator and at right angle. Okay, I hope that you agree. So if this is the equator, and just say for example, we're going to consider this meridian. So meridian north to south. So this meridian, okay, the angle is what? It is actually 90 degrees. So actually all of it measures 90 degrees. Okay? If you want your angle to be well here, so it's still 90. So we can say that the meridian is perpendicular to the equator. Okay? It is perpendicular. Just to make it simple. Next. So we have the prime meridian. The prime meridian is the thick meridian that you can see in this illustration. The prime meridian is a meridian. Okay, it is a meridian, which how are we going to well describe it, or what is its characteristic? Okay, so it is a meridian which passes through Greenwich, England. So in this illustration that we have here, okay, so Greenwich, England is actually located in this well, at this point, okay, here. And the meridian that passes through it, okay, from the north, of course, the meridian is north to south. So north to south, and then the Greenwich, England is here. So this meridian is said to be the prime meridian. In geographic coordinate system, we have the latitude and longitude. So if we would like to know the coordinates of a city or a place on Earth, so we need to know the what? So what we need are the latitude and longitude. So the latitude is the angular distance of the point from the equator. It is measured along the meridian of the point under consideration, 0 degree to 90 degree north or south of the equator. Okay. So again, in this illustration here, so we do have here the north, the south, and then this line here in between is the equator. So how would we know what is the latitude? So it is said in the definition that it is angular distance of the point. So if we do have a point here, okay, so say that this is the point, considering the equator, okay, from the equator, so we're going to measure the angle, okay, 0 degree to 90 degree north or 0 degree 90 degree south of the equator. So the latitude in determining, okay, in determining it, so what you need to consider is the equator. So if you have a point here, so you need to measure the angle, okay, the angular distance, the angle from the equator towards the point. So for example, from the equator towards this point, the angle is 45 degrees. So from the equator going, okay, to the north, because the point is nearer, okay, it is near, rather it is near north. So in writing the latitude, so it is 45 degrees, you copy the angle, and then north, that is the latitude. If ever that you have a point here, 60, okay, if this is 60 degrees, so we're going to write the latitude of this point as 60 degrees, then what? Is it north or south? So from the equator, it is what? South. So that is the latitude of the said point. So to make it short, if the point is on the northern hemisphere, therefore the latitude should be what? Angle. So you write the angle, then it should be north. If the point is on the southern hemisphere, so you write the angle or determine the angle and then put south. Next. So there's a question here. Okay, what is the latitude? So with the arrow, okay, so what is the latitude of, well, at this point? So remember, we do have here the North Pole and then the South Pole. What if the point is, well, located here? So you determine the angle from the equator. Okay, so from the equator, going to the north, okay, stopping at this point. So measuring it, it measures what? Of course, that measures 90 degrees. And then you need to put the north. Okay. Next, we do have the what we call as latitude. So the definition of latitude, it is the angular distance from the North Pole and of L. Okay. So in this illustration again, so if we have the point here, okay, and the point has a latitude of 45 degrees north. So the latitude of it is actually from the north, okay, from the north going to the said point. So you're going to consider the angle. What is the angle here? If point A, so this is point A, is north of the equator, so we can compute or determine the latitude as what? So it is equal to 90 degrees minus the latitude. Again, so if the point is here, okay, so for example, this is 45 degrees north because this is the equator. So the latitude of it, you need to measure the angle from the north, okay, towards the said point. That will be your latitude. Next, if we have a point B, which is on the south of the equator. So, determining the latitude will be equal to 90 degrees plus the latitude of point B. So, for example, um, we have a point B here. Okay, the point B is here. So if this is point B, say this measures 45 degrees, okay? 45 degrees south. So this is the latitude. The latitude of it would be what? So from the north, you're going to what? You're going to determine the angle towards the said point. So north going to the equator, the angle is 90 degrees. Okay, we do have here the 90. Then you're gonna add the latitude of the said point. Since it is on the south of the equator, so you're going to measure it, okay, from the equator. So it measures 45 degrees south. Okay? So you just give the angle. For the colatitude of point A, the colatitude of it is 45 degrees. While for point B, so that is 90 plus 45. So the call latitude is 135 degrees. Okay. So we have here an example. So for example, we are asked of what is the call latitude of Manila. So what we need first is the latitude. What is the latitude of Manila? So it is 14 degrees, 36 minutes north. Class, this is actually from our handout. If you're going to search for the coordinates of Manila using Google Earth, okay, you can use Google Earth. You can also use the search engine. So any search engine, you just input coordinates of Manila. It will automatically give you the latitude as well as the longitude. In the handout that we have, so the latitude of Manila is 14 degrees 36 minutes north. And as what you can see, since the latitude is north, okay, the latitude is 14 degrees 36 minutes north, and Manila is actually what in the north of the equator. So what we are going to do to get the co-latitude is what? So that is the co-latitude equals to 90 degrees minus the latitude. So that is 90 degrees minus 14 degrees 36 minutes. And then you just input it in your calcu. So 90 degrees minus 14 degrees and 36 minutes. So consider the DMS. The answer in your calculus should be 75 degrees, 24 minutes, and 0 second. So we're going to consider up to the minute because the second is already 0. So that is the reason why the colatitude here is 75 degrees, 24 minutes. Next. Another example, Melbourne, Australia, has a latitude of 37 degrees 49 minutes south. And in solving or determining the co-latitude of it, since Melbourne is on the south of the equator, so remember what we need to do for the co-latitude is what? We need to add 90 degrees to the latitude. Okay. So adding 90 degrees because Melbourne is on the south of the equator. So we have 90 degrees plus 37 degrees 49 minutes. Okay, then the MS. So the co-latitude is 127 degrees 49 minutes. So you can also try to determine the co-latitude of other places. So if you like to know the co-latitude of a particular place in which you are interested, a particular city around the globe, so you check for the latitude of it. So using the Google Earth or just by searching it online. And then, so just remember that if it is on the northern hemisphere or it is on the north of the equator, so you're going to deduct its latitude from 90 degrees. If it is on the southern hemisphere or south of the equator, so you're going to add 90 degrees to its latitude. Next. Then we have the term parallels of latitude. Small circles cut by planes perpendicular to the axis NS. When we say NS, it is the north. So we do have north and south poles. So from north to south, so you can see this broken line. This is actually the axis. So as what you can see from the definition of the parallels of latitude, so we have small circles. Um, what are those small circles? Of course, in the illustration that we have here, those are the shaded circles here. So we have this portion, okay, and we also have this portion. So it is said that all points on a parallel of latitude have the same latitude. So continuing, the small circle through points A and B is a parallel of latitude. So in the illustration that we have, we actually do have here two parallels of latitude. The first one is this small circle here, okay? And it is said that if it is a parallel of latitude, then points A and B do have the same latitudes. Okay? Because if this is the equator, so from the equator going to point A, and from the equator going to point B, these two, they do have the same measurements or angular distance. Also, when it comes to the well, whether it is north or south, so A and B are both on the north. Okay, so say for example, point A is on 50 degrees north. Okay, it is the latitude, or point A has a latitude of 50 degrees north. So it means that point B also has a latitude of 50 degrees because from the equator going to the set point, the measure of the angular distance is 50 degrees. Okay? And then it is what? On the north. So these two have the same latitudes. And also, another one, point G here, has also the same latitude. Okay, so from the equator going to point G, so it has an angular distance of 50 degrees, okay, 50 degrees, then north. So this is the latitude. By the way, um, if we have another circle here, okay, if ever, if there's another circle here, so it will be the same. So say we do have here M. We have here Q, then we have here S, for example. So M, Q, and S do have the same latitudes. So the same angular distance. So from the equator going to the set point, so angular distance. And then of course, all of these three are on the south. So they do have the same latitudes also. So after knowing what is latitude, we now have the difference in latitude or the DL. Sometimes this is also denoted as D lat. Okay, D lat. Between 2 points, so if there are 2 points, okay, it is the arc of a meridian between the parallels of latitude which pass through these points. In general, the difference in latitude between 2 points A and B of latitudes L sub 1 and L sub 2 are given as number 1. If points A and B are in the same hemisphere, so for example, both are on the northern hemisphere or on the southern hemisphere, then if the first latitude is greater than the second latitude, then the difference in latitude is L sub 1 minus L sub 2. If the first latitude is less than the second latitude, then the difference in latitude is L sub 2 minus L sub 1. So just to make it short, if the 2 points are on the same hemisphere, simply what you are going to do is just subtract. Okay? You need to subtract the smaller, okay? The smaller angular distance of the latitude from the bigger one, just to make it short. And then number two, if points A and B are in different hemispheres. So for example, one is on the northern hemisphere, the other one is on the southern hemisphere. So what are you going to do? Simply, in getting the difference in latitude, you're going to add the two latitudes. So we have here three places. So we do have Denver, Colorado, with the coordinates 39 degrees 44 minutes north as the latitude. Remember, what we need is the latitude. So just to um well, just to have a clue. So when we say difference in latitude, okay? So the latitude, when it comes to the coordinates, it can have north or south. So what you only need here in solving for the difference in latitude are what? So this 39 degrees and 44 minutes north, this one also because it has the north, and also this one because it has the south. So you're not gonna use the other one. The one with the W, so it means west. This is actually the longitude. So we're gonna have it later. So what is the difference in latitude between Denver and Albuquerque? So if you take a look at the latitudes of Denver, okay, so Denver is 39 degrees and 44 minutes north, and then Albuquerque has a latitude of 35 degrees, 5 minutes north. If you can notice, both are on the same hemispheres. And in the discussion a while ago, in computing for the difference in latitude, if the 2 points are on the same hemisphere, so simply you're just going to deduct the smaller one from the bigger one. Okay? So, of course, 39 degrees and 44 minutes is higher than 35 degrees and 5 minutes. So, you're just gonna deduct. So the difference is 4 degrees and 39 minutes. So it is the difference in latitude of the two. Next, how about the difference in latitude between Denver and Buenos Aires? So looking at the latitude of Denver, so it is on the north, and then Buenos Aires is on the south. So if the two latitudes are on on different hemispheres. So simply you're just gonna add the latitudes. So we do have DL equals 39 degrees 44 minutes plus 34 degrees and 36 minutes. So adding the difference in latitude is 74 degrees and 20 minutes. Next, how about the difference in latitude between Albuquerque and Buenos Aires? So again, you take a look at whether Albuquerque is in north or south. So it is on the north, and then Buenos Aires is on the south. So well, we do have different hemispheres. So simply, we're just gonna add for the difference in latitude. So adding, it is 69 degrees and 41 minutes. Next, we have the longitude. The longitude is the angular distance between the prime meridian and the meridian of the point. The prime meridian, we already discussed this a while ago. So it is the meridian that passes through Greenwich, England. And the longitude, so measured from 0 degree to 180 degrees east or west of the prime meridian. So longitude, what you need to consider is what? East or west of what? From the prime meridian. If the latitude is north or south from the equator, the longitude is east or west from the prime meridian. This is the equator. Next, if this is the equator, so this is the north pole, the south pole. So the prime meridian is this one. Okay, so this is the prime meridian, this white curve here or white arc here. Next, from the prime meridian, so this is the prime meridian. If we have this point here as the point of interest, the longitude would be what? So the longitude will be from the primary region, okay, towards what? So it is towards the meridian where the point is. So for example, we do have here another meridian, okay? So this is another meridian. So if this is another meridian from the north, okay, passing through the said point, going to the south, so the longitude will be measured from the prime meridian towards the said meridian. Okay, and as what you can see, the direction is what? So it is actually going to the east. Okay, next. If a point is 40 degrees east of the prime meridian, its longitude is designated as 40 degrees east. Okay, so just like this one, if we're gonna measure from the prime meridian, the angular distance towards this meridian here that passes through the said point, so this measures 40 degrees. It is going to the east. So 40 degrees is the difference in longitude. For the difference in longitude, so if there are 2 points, a shorter arc that connects the meridians of the points. If points A and B are on both east or both west of the prime meridian, then it is also the same as what we did a while ago. So you're just going to deduct the smaller one from the bigger one. Number two, if points A and B are on opposite sides, so one is on the east, the other one is on the west. So you need to add the two longitudes. After adding, you need to check if the sum is less than 180 degrees. If it is less than 180 degrees, therefore, the difference in longitude is the sum already. If ever that you added the two longitudes and you check whether if it is greater than 180 degrees or less than 180 degrees, If it is greater than, so you need to deduct the sum from 360 degrees, and that will be the difference in longitude. So this is just again to show to you the coordinates, okay, of a point. So we have here the coordinates of Washington, D.C. So Washington, D.C. is 39 degrees north, which is the latitude. Um, Let us well identify the equator. So the equator is here. So here is the point. Okay, here is Washington, D.C. So remember, the latitude is from the equator towards the point. Okay, so if you try to look at the angular distance, so it is what? So it is more than 30 degrees. Here is the 30 degrees. So it is 39 degrees. Okay, next. For the longitude, remember the longitude should be from the primary region. So you need to locate the primary region, which is here. Okay, this arc. And then remember, so from the primary region, so going to the meridian that passes through Washington, D.C. So if this is 0 degree, 30, 60, then this is 90 degrees. So it is in between 60 degrees and 90 degrees. So if we're gonna measure the angle here, okay, the angular distance, so it is 77 degrees west. So we have another one here. Okay. So in this illustration, we do have New Orleans. New Orleans is here. So where is the equator? Of course, the equator. This is the equator. The equator is 0 latitude. And then measuring from the equator, okay, towards the point or towards New Orleans. So it is what? 10 degrees, 20 degrees, 30 degrees. So it is 30 degrees. Therefore, the latitude of New Orleans is 30 degrees north. Next, for the longitude, so remember, you need to locate the primary region. So the primary region is here. From the primary region towards the meridian that passes through New Orleans. Okay, so you can actually see that this angle is what? 90 degrees. So it is 90 degrees, then what? So primary region, from the primary region going to the west, so you put the west. So that is 90 degrees west for the longitude. So this is just to show you the coordinates of the different places. So we do have Berlin up to Washington. Then latitude, longitude. So for example, Chicago, so the latitude is 41 degrees, 50 minutes north with a longitude of 87 degrees, 37 minutes west. Then Manila, 14 degrees, 36 minutes north for the latitude. And then for the longitude, 121 degrees, 5 minutes east. Another one, Tokyo. So it has a latitude of 43 degrees, 40 minutes north, and longitude of 139 degrees, 45 minutes east. So let us now compute for the difference in longitude. With Paris, Washington, and Sydney. So considering these places. So the difference between, the difference in longitude between Paris and Sydney. Okay. So just remember, so what we need to take a look at is what? So the one with W or E. Okay. So let us box it per place. Okay. Now, so difference in longitude, Paris and Sydney. So let us take a look. So Paris is on the east, and then Sydney is also on the east. So remember, if the two longitudes are on the same, whether both on west or both on east, so what you're going to do is to subtract the smaller one from the bigger one. Okay. The difference in longitude is 148 degrees 52 minutes. Next, Paris and Washington. So if you look at Paris, so it is east, Washington is west. So if the two longitudes, on one is on the east, one is on the west, so you're gonna add, okay, you're gonna add the longitudes. Then after adding, if the sum is less than 180 degrees, then that sum would be the answer. If ever the sum is greater than 180 degrees, so you need to deduct the said sum from 360 degrees. So let us add. So we do have 2 degrees, 20 minutes plus 77 degrees, 4 minutes. And then the answer is 79 degrees, 24 minutes. And that would be the answer because it is less than 180 degrees. Next, Washington and Sydney. So Washington is west, Sydney is east. So again, different. Okay, one on west, one on east. So you need again to add. Since 77 degrees and 4 minutes plus 151 degrees and 12 minutes is greater than 180. So automatically you need to subtract it from 360 degrees. And the difference in longitude is 131 degrees and 44 minutes. And that's it for the terrestrial sphere.